So the question is palindromic substrings. So in this question, what we have to do is we have given a string, and from that we have to find out the total number of palindromic substrings that are present in that string. Okay, so for to solve this question, the brute force approach we can see is that using two nested loops we can find all the substrings, and then for every substring we have got, we can check that whether it is palindrome or not in O(n) time. So it is the brute force approach, and it is taking O(n) cube time. So it will give TLE. So the next approach will move towards, like, we can divide the total number of substrings into the substring of even length plus the substring of odd length. So for even length, what we can do is, like, if we are at the index I, we can send the I and I plus 1 index, and then make the count variable, that is checking ARR Si double equals to Sj. It increments the count variable, and then I minus minus and j plus plus, and then check the condition. So what we are doing is, like, we are finding the substrings and the checking the palindrome in it itself at the same time. Means that we are checking for the palindrome at the time when we are getting the substring only. So it is saving our time of checking the palindrome separately O(n) time. So yeah. So in this approach, for even we'll be calling the function for I comma I plus 1 at index I, and for odd length substring we can call the function at I comma I, and then find all the odd and even substrings and then adding that in the answer. So in this way our time complexity will reduce to O(n) square time. The next approach we can use using the DP. So in DP what we can do, we can make an vector, 2D vector, where we are making like that I and j. So dpij, it indicates that whether the substring from index I to index j is a palindrome or not, and we are maintaining this DP array, and at the end we are getting the result from this DP approach by making the count variable and then counting, increment the count variable even when we are finding that dpi comma j is equal to true, means it is a palindrome. For a substring that is starting from index I to index j is a palindrome. So yeah, this is approach using DP, and it is also in O(n) square time and O(n) square space complexity. But the first one, in which we were finding that even odd substrings and odd substrings, there the space complexity was O(1). So the last approach is Manischer's algorithm. So we have to further study about this Manischer's algorithm. So yeah, I'll talk about this later on. Okay, thank you.